of 2023, there was a big hurricane, the Hurricane Otis, which destroyed quite a lot of the airports. But they still wanted to have some aircraft, especially some rescue aircraft and so on, landing, and also aircraft bringing some foods and all the things. So they wanted to have the airport really quick in operation. Because we were just there more or less because we just delivered our NavAid drones there, they asked us for support. You see again my colleague Cedric, who had the chance also to go there. So we helped them to do in a very quick way, in a very emergency way, to do an analysis of their ILS systems. And of course, I think we also like to show this example. Of course, we don't wish anybody to have a disaster. I mean, yeah, but it's prevention. Somehow, it is important to have the possibilities in case one day there is an issue somewhere. It is important to be able to react quickly. And maybe the flight inspection. This is also why I say before. You can use the NavAid drone when there is an incapacity of the flight inspection. Maybe the flight inspection is simply not available now to go there. Yeah? Okay, then you use the drone. All right, I have a last part dedicated to regulatory. Mr. Popka, shall I continue or I do it later? Sure? No? I'm not sure. Yeah.
Hello, everyone. We would observe that lunch is already being served to people in packs. That's because we understand some people are fasting, either Ramadan or Lent. But for those that want to eat now, please feel free to have your lunch. We'll have a 30 minutes break where our Muslim brothers can go for prayers and then come back afterwards. Then those that are not going for prayers can just stretch. We understand that it's been a stretch of hours already, so you can use the 30 minutes to just walk around, move around, network, or meet people that you haven't met before. And then we come back by 1:30. Thank you. Sorry, sirs. Please, we would like to have like a just one after the other during this break. When you come back from prayers. Yes, sir. Okay, hello everyone. Welcome back. I see that our numbers have not returned back to what it was before lunch, but we'll proceed notwithstanding. We are going to run one more session, one more presentation session, which would last for a few minutes before we go into the question and answers. We understand that the question and answer session is a very vital part because that's where we get to answer most of the questions that people have to ask. So we indulge you to please sit with us as we run through this last part. Thank you.
It's working?
Yes, please.
Just coming. Elle tremble la souris là, je pense qu'il y a une interférence. T'as une souris? Ça, j'ai pas ma souris. T'as un stick? Okay. Good afternoon. Good afternoon. I hope those who got the lunch enjoyed the lunch. And so now we change a little bit the program where I will show you now the result from this morning and I will present you the software that we are using and that unfortunately you could not see it this morning because of some logistic issues. So this software is the software that developed by our company, so which is the all-in-one software where we can program the flight plan, monitor the flight and the measurement, and go to the generation of the reports. So it's an all-in-one software. The idea of the software is to make it easy, safe, and quick to operate on the airport or even outside the airport, because you have seen, for instance, this morning, we have in a busy airport like in Abuja, we have quite a limited time available, so we need to be quick to react. In particular, in case of any issue during the measurement or we see any issue, if we want to repeat, we want to be quick to adjust the flight plan and to make new measurement. So for that purpose, in the software, so I am now actually connected to the drone just for to show you. So the software is composed of several parts. One of the crucial parts, we already discussed that with the people from NAMA this morning, is the database. Okay? Like for the flight inspection, the database is the heart of the measurement, because all the measurements that we are doing are using the information from the airport. So if I have a wrong position or wrong elevation of the glide path, for instance, then my measurement will be completely wrong. The measurement is okay, but the positioning of this measurement towards the reality of the installation will be wrong. And so this is one crucial part, is to have the accurate database. You have seen also this morning that we are using this RTK base station, because to get the accurate measurement, we need to fly as precise as possible, but then also the measurement, each measurement sample is stamped with a very accurate position information. So the way of thinking the way we think when we developed this software was a lot inspired by a flight calibration company, this FCS, this German company. So we got a lot of input from experts from flight calibration. So that's why even if today one of the main goal is to replace completely the ground measurement with a much better measurement, all the type of measurement we are doing are flight inspection in the view or in the point of view of how it was developed, even the result. So I can show you a quick example what I am doing when I am on site. So I select the airport which is in my database. I can visualize and check the airport information. So where I will find the important, the localizer, the glide path and the threshold, and then the calculated what we call the projected glide path, which is basically the aiming point on the runway from the aircraft. So from this information, this is where I will be able to derive and to make the calculation of all my flight plan, or when I will start and stop the measurement. So for example, for each type of receiver that we can today measure, we have a different type of measurement profile. So that's what Luc explained this morning. Where for the localizer, we can do the runway course, we can do the near, so different type of sector arc, which will be at different distances from the runway, then the approach, and then even a manual mode. A manual mode, for instance, is very interesting in the commissioning or the pre-commissioning phase, where we will simply we can hover the drone in a certain position and just record, and the technician in the shelter make some adjustments, some changing, and we just measure and we just give them the values. We are in contact, and when they are happy with the settings, we can just land and make another type of measurement. So this is really all the idea. So it's a kind of measurement equipment that you can bring everywhere in the air. So when I select a measurement profile, like for instance this arc flight, I will simply select, again what I did this morning was a 3 degrees minus 3 degrees flight, and I did that at something like, I think it was 5,020 meter. And then I can select the elevation, which I am doing it. Either this elevation is from the localizer, or I can select elevation from the glide path point of view. And then the system will automatically calculate those waypoints. So the user has nothing to do. We just have to select where we are. So from the position we are approximately 980 meters from the threshold, and that was all the basis for my calculation. So I just had to set those two fields, and then the waypoints are created, are generated. Here also, very important, we can then manage the different alarm conditions. So obviously we do not change anything on the transmitter side, but we record the position or the status of the transmitter. So typically when we do our regular measurement, in one flight we do several arc, in one side clockwise, counterclockwise, and then instead of measuring twice the same, we just measure a different transmitter, or we measure different alarm conditions in one flight. So in one flight we do different measurement sections. So this morning we did only one transmitter because we did not manage, or we did not make it more complex to have a communication with a technician in the shelter to make the modifications. So once I have selected my receiver conditions, I just need to add it on my list of measurements, so I can add several measurements, so exactly like I did this morning. And here I will select the position from my drone which I had this morning for the takeoff, and I simply generate my flight plan. Here, part of the safety feature, for instance, we control and we calculate the distance from your position or the takeoff position and the measurement point. So here there is a warning telling you, are you sure between your first measurement point and your drone takeoff position there is 250 or 47 meters. Are you sure you want to do that? And the same for the landing. This is clear because the takeoff position actually is here in the middle in that case. So of course we have a long distance because the first part the drone will be flying to extremity of the arc to make the measurement in one direction and then makes the next measurement in the other direction. Automatically the software makes the calculation of the geofence. So in red you see what we call the geofence. So you don't have to care about how to calculate this geofence. The geofence is the area where the drone is allowed to fly. If for any reason the drone wants to fly out of this area, it will be blocked based on the GPS coordinates, it will be blocked and stop. It could not fly out of this area. Then in addition to that, so here we have the generation of all the waypoints. So this is all what we have to charge to upload into the drone and into the receiver. So when we upload, so using this link actually, I communicate with my drone and I can upload this flight plan into my drone. It will configure the autopilot as well as the receiver. So all in one, is integrated into the drone. So there is no need to configure the receiver and the drone separately. Everything is done at once. And for instance, in that example, so we see the waypoint, and there is a specific waypoint where there is a start command. And this start command is the beginning of the first measurement. So the receiver, when he will reach this point, will simply start the first measurement. And when he will reach the extremity of this arc, it will stop. And so on, and then start again and stop again. And I have my 2 measurements. Okay? So it is as simple as that as we have done it. In addition, we have here what we call a rally point. So again, for the safety, in case of an arc flight, so we have seen that with the pilot can be like 200 or 300 meters away from the drone at the extremity of the arc. For safety, we can add alternative landing point. So we could define from the software, say, okay, if something happened, I define, for instance, this rally point at the extremity on the right, and if something happened during the flight, the tower say, okay, now you have to land. The pilot can trigger what we call the return to launch, and the autopilot will select the closest point of the rally point which are loaded, or the takeoff point. So just to minimize and to optimize the time we need to land and to be on the ground in case of emergency, helicopter coming, airplane, flight coming, anything which was not planned. So again, all this part is really the flight part or the preparation of the mission. It takes few seconds. The longest part of this is to upload this all to the drone. Can take 2-3 minutes just to upload all those information. But this is really the longest time that you need to wait before the takeoff. Just to give you another example of the checkings that we are doing, when we upload the flight plan, we download it after, just to be sure that the autopilot really recorded the right information. So we do upload and download the flight plan, and in the background we compare that the information which we want to send as the one which have been written on the autopilot, just to avoid that the drone is flying somewhere else if there is a corrupted mission or corrupted autopilot memory. So that's also something we do in the background. So really, the idea was really to minimize all risk of failure from the autopilot, all risk of mistake from the software. As Luc told you, we are doing those measurements since now quite a long time. We started the operation, the Colibrex started in 2011. We started our first commercial operation in 2013. So we are operating drones from 12 years. And this is also using some histories we had in the past using, let's say, a platform which we bought at that time just to operate our system. So that's why we wanted to do our own system where we can control and have all the safety features that we want to have. When the drone is flying, so actually here, this is the flight plan from this morning that we have. So we see it was a very interesting flight plan. So remember, for the localizer, we had the first approach flight, so which is the one in the middle here. This approach flight, so the drone was taking off, going to that point, making a first approach, going outwards, and then going back inwards with the second measurement, and then making the arc flight. And you see now this nice complex geofence in red. So that was everything was calculated automatically by the software. So you don't have to care. So it makes to include let's say the smallest area around your flight plan. Here we see, so what I see when I'm doing the measurement, I see here on that part the live measurement. So I can see the DDM values, so the percentage values. or I can see the curve which is drawing during the measurement. Here I have receiver information like the temperature and the measurement which is running, and on the right part I have all the information from the drone. You see there's some information which are in a red background color. The idea also here is in case of any parameters which are below a certain threshold, we immediately warn the operator. So if I'm, for example, if I am in flight, I have my battery which is going below a certain threshold, it will become yellow and then red, so that we do not lose any second to give the information to land. Yeah? So that's typical information. Obviously, when we are in flight, everything is not colored. But because we are inside, for instance, we see now some problem with the satellites. Even if we catch some satellite, only a little bit. And the last things that we do also, you can even see that even we think about the worst case, the worst scenario where our pilot get incapacitated. He has an issue, he cannot control anymore the drone because of any problem. We can even trigger from the ground station the land command or the RTL command. Or even in worst case, I can trigger the parachute from my ground station. So in case of any problem, we have a separate link. So this is also the safety for the remote control. The remote control has its own 2.4 GHz link. Here, using the telemetry link, which is in a different link, we can still control and have some safety actions on the drone, like RTL and land. Okay? So that's the measurement part during the flight. So there is the two things. When we are flying, we record everything obviously on the receiver. We have live telemetry which is coming during the flight, but this is only an extract of the measurement. And this is not the full measurement because the receiver capabilities, the receiver sampling rate is really high, and that will be a huge amount of data that we cannot you cannot send through this link. So we only send an excerpt of data just to be sure that the measurement we are doing is what we want to do. And only shortly before the landing, when the last measurement is finished, we start to download the result. Or the system starts automatically to download the result. And so as soon as we have landed, this is what we will see. So I will get, for instance, let's go for the glide path measurement from this morning. So this is available immediately after landing, or 1-2 minutes, depending on how many measurements I have been doing. So this is then what I will get. I can also increase the flight. Here I will see on this right part the typical values which are coming from the flight inspection. So I will have the displacement error, I will have the DDM angle, the symmetry, etc. Don't have too much look into the data because my database was not perfectly accurate for this measurement, but we have a 3.05 degrees, which would be, I think, still acceptable for a target of 3 degrees accuracy. So what is interesting also here, where I can analyze some part of the measurement. If I zoom, actually, you will see that I have more and more measurement point. Okay, and when I click, I can see immediately my SDM value and my RF level for every point. Okay, so that's the information we can see on the result. I can immediately from this page actually generate a PDF file. So I did it this morning, but I will do it again. And it will simply generate a PDF file where I will see the date of the measurement, the type of measurement which have been done, the calibration date of the receiver, and the software version, etc. And then we just see the same values which we have seen on the software, which are then printed into the file. This is basically what we send to when we do this regular calibration measurement, regular inspection in Germany. At the end of the measurement, the next day, the next morning, I just send those PDF to the German ANSP. And yeah. Also, what we have in addition, we have what we call the export data records, and that's a huge extract of actually file which are sent. Let me see where I grab it. Let me put it here. Okay, I will show you. Okay, actually it's a CSV file. Okay, actually I don't have it's a new station, I did not install the Excel on it, so I'm sorry. So actually we have a huge table, so Excel file, CSV or Excel, where we have the complete all the samples. So you have every single sample which has been done, typically for a vertical flight like this one. So this one is the vertical result. Okay? So, yeah. With that, actually the ground, so there is two things. You can see you are above the tolerances, so you'll be fine. You see your 3 degrees would be acceptable. You can see your symmetry or not, if it is fine. So there is the first aspect. So this is, let's say, the flight inspection mind. You make the measurement and you have to be within the ICAO tolerance. But then there is the ground inspection, or let's say the one which want to improve the system, and then they can do a deeper analysis on the result also. And then they can play also with the settings and make a new measurement. So you could, for instance, decrease a little bit this bump and have something more smooth, because normally the glide paths make more like a smooth S form shape ideally. But okay, it can happen with some phasing issue from some of the antennas. But that's also some part which can be fine-tuning, and this is the advantage of the system. When you have the system in the airport, you can do this adjustment, see the effect, reverse if the effect is not as you want, as you expect, and so on. Then in addition, we did so the approach flight. So here it's interesting because I flew. So we flew this. So we follow, as I said during this morning, the big difference with the flight inspection. The flight inspection is following the DDM0 and give an angle. Here we cannot follow the DDM0 because we don't have a pilot. The autopilot is not following that. So here we follow 3 degrees. And then we have a displacement error compared to the theoretical DDM0. So in that case here, based on my database, I was flying still minus 10.3 DDM average, and I think if I see here in my vertical result, I have 10.5. So that's just to show the correlation between my horizontal flight and my vertical flight, because there is one crossing point, and so that match. Those two are matching based on the database which I am using here. Okay, and then we can see then the second. Can change the color. So remember, we did 2 approach flights, so I can select the colors and I can just display. And then we can see, so that's then the overlay of the 2 measurements. Okay. And again, here we are still within the tolerance line, according to ICAO. Then for the localizer, so we did also 2 approach flight. So only 3 degrees because of the distance. At this distance, we cannot do much more. We could do 5 degrees, but then we push to 500 meters from the side. It is possible, but okay, for the purpose of the demo, I didn't want to push too much. And there was some small houses on the left. And again, I select my values, and here I will see then the DDM values. The localizer is typically more rough values because they are not filtered, and I think the other flight was slightly better. Yeah, so still within the tolerances. So this is then the localizer course measurement. That's only a 250 meters flight, so that's quite a short flight. Okay, and then we did the clearance on which sector, and in that part, we want to see, so again we have the sector width here. I can zoom, yes. Okay, so we have the sector width from our measurement, and yeah. So again, here I'm not 100% sure about the sector width of this localizer. This is a calculation that we could do based on the length of the runway and the width, so we could measure the sector width of the localizer, but we are not too far from the designated or from the target, and this is symmetrical. Okay, so we have a symmetry from the localizer, so the localizer is quite fine, no issue with it, and we did the measurement between -3 and +3 degrees. Okay, so that's basically the measurement we have been doing today. I can show you quickly some measurement that we were doing, that we have been doing in Germany. Maybe just to show you a difference between when I overlay different alarm conditions. So I take a random measurement. Let's see. transmitter 1. So you see here actually I select, so I've selected here, what do I have selected? So from the runway 26L ADDP, I don't know which airport is that, but it's okay, it's an airport in Germany. And here it's always the transmitter 1, and then we have the different alarm conditions. So the 90 Hz, 150 Hz, then we have the narrow, course narrow, and then the course clearance wide, and then the normal conditions. Okay, and this is then I overlay. And then you see the effect also of on the signals when in the different settings of the alarm. And this is exactly what Luc said. Then we can measure those alarm conditions with the drone, and we do not need to make additional run with the flight aircraft, with the flight inspection aircraft, just to measure those alarm conditions. So that's exactly what we are doing. Well, do you have any question regarding the software? Specific questions, or everything is at the end? How about the process? Again, here the complete idea here is really to have it easy to use. And honestly, for us, I have been doing a lot of different kind of measurement. This is really nice measurements to do, because the software is doing almost everything alone. I just have to be sure that everything is set correctly, but then the operator. So for someone to operate the system, it is easy. Obviously, there is a huge experience on the flight conditions and the settings of the mission, but for this specific application, using this system, it is really fairly easy to use, even to the generation of the report. So that's, yeah.
Okay. Yeah, this was now a very important part, I think, for you to really see what we have on the ground control station from the real measurement that we have been, that we did this morning. And I think Cedric also explained you a bit how we use the software, how we do the mission planning, how we do all the safety controls on the flights. And we believe, we consider that is really one of the key issue of such a system. Now, if there are not yet questions to the measurement of this morning or further question to the software, let me just go to 2 or 3 additional points regarding the system. Not only the software, but the system. I will pass a bit through a few things. Yes. Let me just recap somehow what we are talking about when we consider the NavAid drone. As I already just said before, it is not just a drone with a NavAid receiver. It's a fully integrated system where every equipment, every piece of component here is somehow adapted to the complete system, and where the software, as you have just seen, plays a major role. Yeah. Having said that, a few a few information also about the drone. Meanwhile, today on the market you can find so many type of drones, commercial drones. You can the market is actually dominated by one player, which is a DJI from China. Some of you may know they are producing some toys, some very small drones, and some more professional drone, and it's widely used, especially for inspection related to cameras, yeah, inspection with cameras, or LiDAR or infrared cameras. There are so many applications. When we are talking about measuring the ILS, the problem is that you have to consider some specific issue. Let me give you an example. You may want, if you have seen maybe already some other drones, you may wonder why we are not using carbon propellers. Because most of the drones nowadays are built with carbon propellers. The problem of carbon propellers is that they are producing so-called propeller modulation. They are actually producing RF signals, and unfortunately for us, we can say, at frequencies which would disturb the frequencies that we are measuring. Yeah. That's why in our case, as you can see, we use APC, so kind of plastic propeller. And also a particularity of our design based on this FCS receiver technology I mentioned this morning. This receiver has some special algorithm in order to mitigate multipath propagation which could occur. Yeah? That's very important because we go very deep in the signal analysis to do this kind of measurement that you have seen before. And so the signal at the end, the data that we extract, that we proceed, must be cleared of any potential influences. Yeah? Influences could also come from the drone, could also come from the frequencies we are using to control the drone, and so on and so on. So all these things you have to take care. This is why we always say, when we have the chance to explain a bit what's behind the solution, we always say in a very simple word, it is not just a receiver mounted on a drone. That doesn't work. That would not work. Or let me say that in another word. You would maybe measure something, but is it right what you measure? That's the key issue. Yeah, that's the key issue. And so we put really a lot of efforts here in this system integration, doing a lot of measurement campaign of testing, yeah, to come at the end to this solution. Another particularity of the solution, as I say, it is not an off-the-shelf drone. It is not a drone that we just buy on the market. It is a drone that we integrate, that we manufacture by ourselves. That gives us the full control of everything, up to the autopilot. The autopilot, it is the head of a drone somehow, and with the software that we have just seen before, with the software we have access to the autopilot to do the complete flight programming, but also during the measurement to get the data from the autopilot to correlate them with what we measure. Yeah? And that's somehow also a specificity of this FCS receiver that we are using. The receiver talks directly to the autopilot. We have a direct communication between the receiver and the autopilot. And because we decided some years ago to develop our own platform for this specific application, we decided not to compromise at all the safety, because we consider that operating such drone in critical environment like airports, safety is really the top priority. That's why I explained this morning to some of you when you just saw the drone, and there was also a question of the endurance, for example, of the drone. I said the endurance of this drone is not so important somehow. It is not the key issue. It was not the key target of this drone. If you want us to build this drone with the maximum possible endurance, we can do it. Yeah? We will put more batteries, we will put maybe less motors, we will put less redundancy, we will do it in a different way. Here we have to concentrate on what is the application. And the application is the type of measurement we want to do, and you have seen the endurance is far enough in order to do even several runs of measurement within one flight. Yeah? But in parallel, the safety is the key aspect. That's why this drone is, its characteristic is the redundancy. It's built, you see, with 8 motors, 8 speed controllers, 4 batteries, some redundancy paths also in the so-called power distribution board that we have. We use some very strong regulators. We really want to maximize the safety of the drone. And when I'm talking about the battery, also here I explained that to some of you this morning, but maybe for the others now. As I said before, some drones, even for some other project, we are using such kind of drones. The easiest way, meanwhile, is to use a very big battery. Yeah? You can find batteries providing you 30,000 milliamp with just one battery. So the battery itself will have a weight of 3, 4, 5 kilos. It's crazy, yeah? The problem of these batteries, they are not so easy to transport. Part of the criteria that we put in our specification when we designed this drone was the possibility, at least to have the possibility, to transport the batteries of this drone in a commercial airplane. And actually, I can tell you, we had some batteries here for another project of this drone already here, but to be sure, Cedric and me, we came from Germany, a commercial airplane, yeah, with battery. Yeah. We were allowed to take this battery as hand luggage because these are 7,000 milliamps battery. They are just below the limit of 160, I think, 160 watt hour. The limit in order to take batteries with you as a hand luggage. So these are simple things which, okay, you might not think immediately, but when we and you know, I say this morning, for us it's important also to be drone operator, not only just to supply the system to others, also to operate by ourselves. We have conducted projects overseas. We have been some years ago to Colombia, for example. So we know what it is to take the drone as a hand luggage or as a luggage, and to take battery as hand luggage, and. So these kind of things are also part of somehow the design and of the concept that we have. And the last point also about the architecture of the drone with the autopilot. I say the autopilot is something very, it's the heart of the drone. We are using an open source autopilot. It's the so-called the Pixhawk controller. And that's for us quite important because it's an open source. So we have access to it. Yeah? We are not linked, we are not limited by some constraints that a not open source product could bring. Yeah? And to give you an example, I mentioned before this example of the DJI drones, which are very good drones, no doubt. But for certain application, it's a question. Here we are operating in an airport. That means actually in a no-fly zone for drone. And meanwhile, the commercial drone, you know, they are in the autopilot. The no-fly zone are embedded in the autopilot and it's basically a good thing because nobody wants you to use the drone in the airport. But we want, because it's our specific application and because we work with the CAAs and so on, we get the authorization, we know how to do it, so we have the control of that. Yeah? With, for example, a DJI drone or others, you need to ask the manufacturers every time, you need to unlock the systems for you. So that means you need to send data, you need to get a response. It's not confidential anymore what you are doing. So there are also issue of security. This is something also we forgot to mention. For example, the data transfer that we are doing is on a special binary format that cannot be hacked. Yeah, also important because we are operating here safety to measure safety critical installation. Yeah. Good. So that's what I wanted also to ask about the safety features. Yeah, all this redundancy, all the mechanism you see also in the preparation of the mission that Cedric explained with the software. We have this flight termination system, all these things. We even have this emergency parachute, which is not the solution for everything, we have to say, but you need also to be at a certain altitude so that the parachute can open. But in some countries, because of regulation, you are asked to have it, and in some other countries, it's very interesting. It's seen as a kind of ultimate solution, but actually, in many places where we operate, we even are obliged to deactivate the parachute, the emergency parachute, because especially if we operate in a busy airport with different runways, yeah, what we really want to avoid is a flyaway. As we explained with the geofence and all those things, there is normally no risk to have a flyaway. But okay, ultimately, we never know. And so the regulator, some of the regulators says, in case there is an issue, I prefer your drone comes down, then it deploys a parachute, and then there is wind, and then there is a drift of the parachute, and then you cannot control really anymore your device. So just a side remark to say that this emergency parachute, the system can be delivered with an emergency parachute. It's part of the safety procedures, but it depends a bit on the use case, on where you operate, and especially on the regulation. The receiver itself, I think we already mentioned a lot. What I have not, yes, also the capability, VOR. We are also working on some new capabilities, but that's maybe something for the last session, for the Outlook. So all it is a very, very versatile and very flexible system. And one thing, Cedric, I think we haven't spoken so much about the antenna yet. Huh? You have seen on the drone this black antenna with the two slides there. This is also not something you can find simply on the market. This is an antenna which has been specially designed, has been specially tested. You see, there have been also some tests in acoustic chamber and so on, because the antenna is part of the system, and the antenna, the receiving characteristic of the antenna can be also influenced by the structure of the drone. So using this antenna on another drone might not give the same results. Yeah? That's why we say at the end it is one system, it is one measurement system which shall be integrated and tested as a whole. Yeah? Very important. So, and here initially at the beginning we had a bigger antenna and so, and meanwhile we came with this design. We are very happy to have it because it's quite compact, as you can see, and it's a dual combi antenna to do VHF, UHF, so to do localizer, glide path, and VOR. What else to mention? The RTK system, I think this has been explained very much in detail. Also the importance of the survey points. That's really a key element. There are also some concern. There are also some concern when we are talking about safety. For example, with the risk, because everything is based on a proper GPS signal, with the risk to have GPS jamming or GPS spoofing. Yeah? So you have to know the technology that we are using here. This RTK device has some anti-jamming and anti-spoofing characteristics. Yeah? So also here some additional safety measure in place. Maybe one word about the calibration we have not yet mentioned. Of course, to allow a proper measurement and to guarantee the accuracy of the measurement, the receiver must be calibrated. So there is an initial factory calibration, and then the receiver has to undergo a yearly calibration. And one very nice feature of our technology, of our solution here is the calibration can be done also remotely. The receiver must not be sent back to Germany. It can be sent to Germany and we do the calibration, but with a certain setup and with a calibrated generator and a calibration interface that we provide, the calibration can be done remotely. So that's quite useful. The VOR option, I mentioned it with some example before, and when we do our presentation, we always insist on the software. You had the chance not only to see a live demonstration, to see the drone flying, and to see the software operating, but that's really for us a key element. The idea to be able to manage the complete workflow of a measurement, from the database, from the setting of the RTK of the solution, of the measurement program that you want to conduct, up to the controlling of the drone and the measurement during the mission, and up to the download of the data and the generation of the reports, everything with one single software. That's quite unique. I don't know anybody else doing it like that. And obviously, with the system, of course, there are also some accessories, like the ground control station. You can see here. The one who have been behind the screen this morning, I've seen even with a very with a very high light, the visibility is still very good because we are using a very professional screen with 800 or 1000 nits. Yeah. So that's also very important. We also provide a battery charging station, everything you need actually to operate the system on the ground. Good. I'm looking at the timing and of my colleagues. Maybe here I think this is also something you saw, the way we operate the system. In principle, two-way operation. A pilot which has to be trained, which is responsible for the assembly, the setup, which check together with the payload operator the mission. We can also do the maintenance, and then the payload operator, who is somehow also the measurement engineer when you operate in the field. For us, we really recommend this so-called 4A's check principle. The idea is that the pilot can help the payload operator during the operation, and the payload operator also help the pilot during the operation to visualize some telemetry data, to visualize also the airspace. We are not saying that, I mean, on a pure technical point of view, the system could be even operating by one person. But we believe it's more comfortable and more safe to operate it at least by two people. Yeah. And some of the rules, some of the drone regulation in place require this 4A's principle to operate. And maybe talking about the regulatory framework, let me come to that point. I skipped this morning. Yes, maybe. Sorry, it's a little bit long text, but I think it's quite important. Yeah, when we want to operate this NavAid drone, what is the regulatory framework that we have to consider? And I see here three categories. The first one is the regulatory framework in terms of measurement. Yeah, I mentioned this morning the compliance to ICAO. It's a little bit, it's a topic which needs maybe some further discussion, because today in the ICAO Doc 8071 there is no dedicated chapter on drone measurement. Not yet. It will come. It is in preparation, but not yet. But that doesn't mean that you cannot operate the drone, because actually with the drone, when we use it to complement or to do the ground inspection, like I explained in the introduction, yeah, we fulfill the specification, these so-called measurement uncertainties, like they are specified by ICAO. Yeah? These uncertainties have certain limitation. They have set for stationary equipment, and with the drone we are moving. That's why the second part here is very important. The accuracy of an airborne measurement must be guaranteed actually, yeah, in a dynamic state. Dynamic state means we have to consider things like the position fixing, the coordinate transformation, the latency times, for example, of the received signal, the RTK accuracy and the RTK integrity. All these things have to be considered when you do at the end a validation somehow of the solution. So today, how do we operate the system? Actually, the national ANSPs or the regulator, depending on the organization in each country, yeah, are allowed to validate the solution, yeah. But this should, in our opinion, should really put attention on the choice of a proven supplier with solid references and with a validation process of its certificate of compliance. That's what we did with the DFS. Okay? That was for the measurement part. On the drone regulation part, that's of course very much dependent country by country. You have some national rules, sometimes some regional rules. So we operate here in Europe, for example, in the so-called specific category. We have to give to the regulator a CONOPS, a concept of operation. We even have to give a SORA, so a risk analysis, with mitigation measures. These are quite common in aviation, a little bit new for the drone industry, but this is something not so complicated, and we are also willing to support our customer, the users of the NavAid drone. And at the end, of course, you need also to get an approval of the airport where you are flying, and to establish a proper coordination with the tower. So that can be done via briefing sheet, operating instruction, a clear communication protocol with the tower, and up to a so-called emergency response plan. These are the things which are normally standard when you operate in airports. So that's what's to complete this second part, and I think we will move now to the Q&A session. Il veut speeder tout d'un coup? Attends, je vais remonter ma première page.
Hello. I have not introduced myself all day, so take this chance to do it. My name is Dr. Bob Gadanjuma. I'm the CEO of Liviasoft. At this point, we would like to go into Q&A, and I'll be the troublemaker here. I'll point at you and say, hey, what do you think? And get you. We want it to be engaging, to get as much questions. Those that we can answer, we'll do it. Those we cannot, we'll note it and make sure, and the name of the questioner, and we will try to get that question answered and sent to you via email or WhatsApp if we have your number. Okay. So you good? Okay. We have a mic. Just can we switch that one off? You can be doing, pull it out of your pocket and then be switching it on and off. Yeah. So you switch it on when you want to speak, I believe. Okay. I will start by asking a question. Who thinks that this NavAid drone is here to replace a calibration, a proper traditional calibration aircraft? By show of hands. Good. That means part of the reason why we're here, there is no misconception. This thing here does not replace it at all. It complements it. It does some few things that the bigger aircraft, it will still do, but then this will do it a little bit better. It's easier, you have two pilots, there is less risk, too many advantages. So, anyone, just raise your hand, we'll bring the mic towards you and you can ask your question. Okay. Where is the other mic? Yeah. His hands is up. You just run to him. You don't need a gym anymore, so just this is good.
Good afternoon, ladies and gentlemen. My name is Engineer Christian Chukwuemeka, a staff of NCA. I want to thank you, first of all, for both the demonstration and also the explanations that of the calibration results that we got today. What I want to ask is the PAPI calibration. Does your equipment also do that? Because I didn't see anything that has to do with PAPI in all your explanations. Thank you.
Thank you for the question. I even have some slides for you on PAPI calibration. Is it here? I don't see anything. No. Okay. So, to answer your question, this is an application that you are currently developing as add-on to the NavAid drone. We decided to really focus first on the ILS VOR because these are the most challenging one. Yeah? And our idea or concept for the PAPI calibration is to be able to use the same drone, yeah, and just to replace the NavAid receiver payload via camera payload. Right? This is actually what you see. What you see here. Yeah? You recognize our drone. The payload has a bit different shape here, and a camera which is then also controlled by the same system, yeah, and by the ground control station. And you may know that here ICAO is a bit more further with PAPI calibration. There is already a kind of specification or amendment on what to do. Yeah, so it's relatively easy actually. To fly at different altitude also, and to determine the transition angle between the red and the white color. Yeah, and so the typical distance to do that is a minimum 300 or a bit, but we consider to do it a bit more far away. You have some other possibility of measurement. This lateral, the azimuth range should all be checked. Can also be checked relatively easy with the PAPI payload. So as I said, our concept is the camera as a swappable payload. The configuration, and that's an important thing, the configuration and the visual tracking and everything made also via this ground control station. That means that the complete mission planning and also this effect of maybe a terrain which is not plain, yeah, or like we have here, we have some difference of distances, some difference of altitude between where the drone will take off and where the PAPI light is installed. Yeah, all these things, this is already considered here because we need this consideration for the ILS measurement. So this is already in somehow for the PAPI. And so the concept of this PAPI add-on, which will come now in the next month, it's first of all an add-on. So you can already have this drone and then install the PAPI later. Yeah? And the concept is the so-called bird eyes view in-flight assessment. The idea is actually the drone will replace or works like the human eye in the aircraft. Yeah? Just that the human eye is in front of the ground control station, receiving his image via the camera, and is not sitting in the plane. That's the first step. If we look a bit more into the future, we have already started some plans to make a more automatic analysis where you have some advanced image processing and also artificial intelligence. So that's how we will do the PAPI. You see, even part of the software is already some of the menu are more or less prepared. The idea is really to go to the different altitude, to measure the transition angle, to detect when is the transition from one color to the other, and to take that in the measurement report at the end.
My name is Jack Pasakoi from Sierra Leone. If we have agreed that the drone system will not replace the traditional calibration of NavAid, and we're all aware that the traditional system is very expensive, and so we are looking forward to the drone in the near future to move ahead, cut down costs for airports, especially small airports like ours. But now, we are now going to be faced with two costs. The cost of the traditional calibration and the cost of the drone calibration in keeping our airports safer. So, one, what will this cost of this drone calibration looks like? Of course, most of us sitting here, we know what's the cost of the traditional calibration. So these are areas I think we need to throw some light, because as a manager, I'm looking at my budget and how to spend.
Yeah, no, it's a very, very valid and very, very important question. I see it a little bit differently. I think it's if you would draw a line of the costs, the more drone you would operate, of course, you will have additional costs for the drone. But in parallel, you can already decrease the cost of the flight inspection. For us, this is the key. As we said, it's not a full replacement, but I hope I gave this morning some example with the pre-commissioning with a reduction of the flight inspection scope of work, not measuring the alarms, for example, or others. I hope I gave enough example that you see that it's one thing will complement the other, but somehow the two curves will intercross somewhere. You agree, or?
Let's look at another scenario. So you're trying to calibrate an ILS, right? Have you had an experience where you have to go maybe 3 times with the big aircraft, or 4? Well, you could reduce it to just 1 when you use your drone multiple times. So you could run your drone 20 times. Each time you come back and make whatever adjustment you need, and then get your big aircraft, a Cessna or whoever is going to come and do it, come once, tops twice. So do the math in your mind. If you're flying the big aircraft 4 times, as an example, versus the drone 20 times, to now reduce your 4 flights to say 1, tops 2, you get your calibration all done. If you look at that number, you would know that, well, yes, you still have to do, ICAO wants you to do the traditional calibration with the aircraft, but having your NavAid drone reduces your cost right there and then. So I hope that scenario is of help. Let's get the mic back to him.
Maybe one additional comment. You would be surprised to know that recently we have more and more inquiries also from flight inspection companies. So flight inspection companies are also looking more and more into the possibility to use that to make their operation more efficient. Yeah. Of course, it's a business at the end, and yes, they charge flight inspection hours and so on, but sometimes, if you allow me, in 2 minutes, I have been last July to the IFIS Congress, International Flight Inspection Symposium, where all these people from the flight inspection industry are meeting. And meanwhile, they have a very clear statement. They say, yes, we can see the drone as a kind of threat, but anyway it is coming. First of all, anyway it's coming. So either we embrace it, either we do something together, or anyway, believe me, the pressure is, in some countries, the pressure is so high that the drone will do part of the job. So the better approach is for the flight inspection company, and that's why, for example, we are doing it with a flight inspection company, with the FCS. The better approach is to think ahead, to think in the future, to think a bit out of the box, as we say, yeah, and to see how can it complement. And if maybe, yes, I can give you an example. FCS knows very well, because of the program of the DFS to use the drone, they will, in future, or already, it has already started, they will do less, they will charge, and they will conduct less flight inspection hours for the DFS. Does it mean that their business is now completely killed? Not at all. They are concentrating on other things. Yeah? They have also more times to do other type of inspection, or to cover other countries, or. So we really have to see it like that.
Good afternoon. My name is Captain Jim Hassan, and I happen to be a calibration pilot, and the one that flies the Nigerian calibration airplane. I came here this morning to hear that my job is going to be eradicated. Yes, but I have done some researches on drone for calibration. I knew that it's a complementary equipment. I have a technical question. When you're calibrating the VOR, when you do that orbit, how far from the 8 do you fly, and how high do you have to fly to do the orbit? That's number one. It's either you answer the questions as I ask them, or you wait until I finish.
I can answer the first one.
Okay.
Actually, again, with the drone, what we measure for the viewer, the main target is to measure the error bearing. And for that, we measure typically 200 meters and a height of 60, 70 meters, depending. So that will be also depending on the surroundings. But we do not fly, we do not fly nautical miles again from the viewer.
We do 10 miles.
Yeah, we do that. We do not do that. It's impossible with the drone.
Okay. Then secondly, this equipment, ideally, if you have an airport like Abuja, how many of those do you need ideally?
In Abuja airport, you will need only one.
Only one, right?
Yeah.
Okay.
And you can even move it around again, having an inspection plan, depending, I mean, a week in Abuja, a week in Lagos, a week somewhere else.
Okay, what about the support? Maintenance support?
Come to that. Just to finish this question, I see the Mexican, for example. They have several airports, and so why did they purchase 11 of these NavAid drones? They have 5 regional centers, 5 regions. So their idea was to allocate 2 drones per regional center to have also some backup, some redundancy, which might be also good, and 1 for their central organization. And at the DFS, for example, the plan is similar. It's to have 1 per regional center.
Okay, there's one question that I'm not going to ask at this forum. The cost of acquiring it. I'm not going to ask that question because it's fault. I represent the training institute of the agency. I'm a deputy director of a training institute. So I'm very much interested in the training because I trained to be a calibration pilot. I knew how long it took and how expensive it is. So what training do you have, and how long will it take to train a person to professionally handle the calibration? That's the 2I.
Yeah. No, thanks. Very important question, because at the end, the idea is that you have the equipment in the different locations, in different countries, and that you are able to operate them locally. Yes. In terms of training, we do offer training. There are 2 parts: the operation of the drone itself. This and most of the time we combine the training for the drone pilot and for the payload operator, because of this 4 A's principle I mentioned before, with the idea that some of the exercise can be done together. Yeah. What we do not, but we have some other organization who can help us also to provide some basic drone training. In general, people who come and who learn to operate this kind of drone, they already know a bit how to use a radio control. And then the purpose of our training is more to explain all the safety functions, how we do the assembling of the system, and especially how to manage the fail-safe situation in case there is something. This is the key. Now, to answer the question, the other part is the payload operator, the measurement engineers. And that I would say is probably the most, not difficult, but most advanced part. So we provide this training. Of course, we expect here people who knows already a bit what is an ILS signal, what is a glide path, DDM and SDM value and things like that. Yeah. We are not providing the theoretical training for that. We could via some partners, but the idea is really then to explain how to use the ground control station in combination with the drone. And your question was the duration of such a training, typically 4 or 5 days. But the experience, we have to admit, the experience has shown that a kind of refresher training might be useful, or what we would really recommend is on-the-job training. Is, for example, when we go, even if your people have been trained, when you go the first time to do the first measurement at a certain airport, also that you have also somebody from us doing this assistance and doing on-the-job training.
So the training, do you come to provide the training on site, or the candidate will have to go to Germany?
Is a combination. If you have the budget to your staff, say Baden-Baden in Germany for that, yeah, you could look for 2 weeks or 3 weeks training. And then there is the local one, which based on our involvement as Liviasoft in this structure, we like to have longer on-the-job training on ground. And since I'm speaking, I will just talk about the drone pilot inside. So without NCAT or NCAA approving us, we have been running a drone piloting school. We have 6 of our staff. They have their A1, A3, and then they have their A2 certification. Can fly this drone, and you saw only one person flying it today. The rest, the other four or five of them could do that. So, and one thing with as a captain, you have to get your what's that terminology when you have to recertify? Not recertify. You have to keep your For drone pilot, you have to do the same thing. Muscle memory. Before you know, you forget it, and then you would push the wrong button and do something, and that drone is coming down crashing. So, how do we do that if we are pushing that training for the drone pilots happening abroad or someone from there doing it? So we're trying to do that locally here. So that component you're talking about, we would handle it locally here, training the pilots, the drone pilots, to that proficiency, and continue to do that continuous professional development for them locally here.
Yeah, because the NCA will need to certify the drone pilots, and in Zaria, we actually applied to NCA to give us the certification to start training drone pilots. Yes. Because I'm asking this question because it has not happened yet. We don't have the certification to train drone pilots. So
yes,
that might be something that we need to
I was speaking to Dr. Yakubu Ibrahim earlier about our interest in drone pilot school and so on. So I know that is going on. Hopefully soon NCA would regularize all of those, have you approved, and others can now partner with NCAT to do that. But yes, the training aspect is important. Let's do more locally here and keep some CapEx down. So,
just one additional remark. I said we are not providing this theoretical training about ILS, but I forgot to mention we have also a partner. We have the DFS Academy in Germany. It's really an academy of the DFS, training academy, and we are working with them also for some specific customer. We can also organize that kind of training. Yeah.
What I just said last is that the training is customized. It's not a boilerplate or cookie cutter for everybody. No. If NAMA, for example, wants to do that, we do the analysis to see the strength, to see where the training needs to be focused. Whatever happens abroad, we'll repeat that locally here. And the same goes for our neighbors, Ghana or Sierra Leone and so on. It's easy for us to move within our region to go and get some of these things done versus someone from Germany to come do it here. So part of the value proposition at the end of the day and the push is for us to be able to have drone pilots locally here and the analysts locally here. A couple that are fully trained can do all of this that he would do. So you'll be out of job, but hey, that's fine.
Good afternoon, everyone. My name's Chu Ahmed Abdul from INCAT Zaria. In addition to the last question that you answered on training for the pilots, I hope the technicians also are included in this. Though your last statement mentioned analysts, I believe the analysts consist of the technicians, the engineers and technicians also, because what we saw today rests not only on the pilots. it's a joint work. Now to my questions. I have series of questions here. Most of them have been answered by some of the earlier questions and the explanations you gave, but those areas that are still not too clear, I think we will answer them together. The first one I penciled down is the peculiarities between the conventional flight calibration system and the use of drones. Then, during the exercise, the practical exercise, why a precursor to the first question? During the practical exercise, there was mentioned of orbital movement. While I observed the movement of the drone, I didn't see anything orbital. Then from the degree of movement that you have portrayed to us here, virtually what I'm seeing is horizontal and vertical. So I will want more explanation on that. Then when you were explaining also, you made mention of approach path. That means it's not possible to actually get the status or the readings of an approach path directly without comparing with the horizontal and vertical procedures. So those were the questions penciled down.
Okay.
Thank you.
Okay, thank you for your questions. So the first one regarding the measurement from the flight and regarding the measurement with the drone. Again, here we start from what can be do on the ground and what we replace from the ground, okay, and then we come to the position where we do. You speak. I will also answer also to your question about the orbit flight. So then we do what we do, like the approach flight, but again, we cannot do the same approach flight like they are doing with the aircraft because we cannot fly 10 nautical miles away or even further away. Like the orbit flight, we cannot do it so far away from the localizer. Point for you, it looks like it is a straight line, but it is not. The point is we are now think about that. We are 5,000 meters from the localizer, and we do only 6 degrees. So it can looks like actually arc flight, but it is not. So if I do 0 to 360 degrees, you will see a circle. You know what I mean? It's just that the center of the circle is based on the localizer. So that's why it looks like a straight line, but it is not. It is slightly turning a little bit. Yeah. And what was the last question? And the last question was about the combination of the glide path, vertical, and the approach. No, this is not a need. We just did it because to optimize to make several measurements in the same flight, but there is no need. What we like to do is when we do the approach flight, we like to do vertical. When we do the pre-commissioning, we do vertical at different distances, and then the approach. And then we can also see at different distances, first of all, the correlation between the approach flight and the vertical. So we pick the points, and this is how actually we correlate with the flight inspection. When we do a vertical at 1,000 meters, I have a displacement error of, I don't know, -2, and then we check the flight inspection report, we check the same position, and we see, we have -3 from the flight inspection, so we are fine. You know, so this is how we do the correlation also between the flight and the drone measurement.
Okay, sorry. The last point I mentioned, the training. Is there anything, for the engineers and technicians, is there any program in place for them also?
Yeah, so as Luc mentioned also at the beginning, so there's different things. So Pogba mentioned more about the pilot training. There's also different level of pilot training. The one who doesn't know anything about drones, this is typically not what we are really covering because we are not a drone pilot company. We train the pilot to our system, but then there is the basic. It's like you know how to drive a car. We will train you how to pilot this specific drone, and then it's a joint operation. Definitely, we need a cooperation between the pilot and the operator. And what is true is that in this system, the operator is also doing a lot regarding the flight planning. You have seen I program the flight plan. Then the cooperation is I discuss with the pilot about what we do the flight plan, and this is the most important part. This you did not see, but he knew the flight plan, so I told him already what the drone will be doing, where we will be flying, how many flights we will be doing, that he knows what is happening. Because if I tell to the pilot, first thing the drone will climb to 5 meters, he will go into that direction, and the first thing the drone to do is going to the left, he has to stop immediately the flight, because there's a problem. So that's the cooperation between the pilot and the operator is also crucial. That's for the safety. We are sure that because the pilot is not controlling the flight, he's just there in case of issue, he stops the flight, he brings the drone back. And for that, he needs to know exactly what the drone is doing and not to be surprised if the drone is standing in the air for 20 seconds because we are changing transmitter, for instance. So that's definitely, there's a communication protocol between the operator and the pilot.
By technicians, I would assume you meant someone back at the lab or at your store that maintains your batteries and can change some parts if you're replacing that, right? Just to be sure, if you can define what you meant by technician so that we're sure we're covering that here.
Yes,
define it a little bit.
It includes those, but this morning we saw the drone pilot standing somewhere else while you have the engineers and technicians putting in the data and then directing in communication with the drone pilot, directing where the drone should go, or actually working with the app that was within the system.
that's the operator in that regard.
Yeah,
okay, so you call it technician. Okay, because terminology we wanted to be sure. I wanted to ask that question so that we're sure where we are. So
in this case, we call it the accepts.
Accept. Okay.
Accepts, yes.
Okay. Great. So the training, as I mentioned earlier, needs to be customized based on if he's going to be trained as a drone pilot, just what his fingers would do because he knows everything else. But if you have someone that is fresh, green, then you have to do more. So there is no specific one that covers everyone, but you have to get it customized at the end of the day. So further questions? Thank you for that clarification. Yeah.
Good afternoon, sir. My name is Surveyor William Nkerem. Because at the end of the day, we are talking about the data management for accurate flight calibration. My concern is from the software, does it have the capability to detect GPS interference that will pose a threat to the quality of the calibration result? Second question, on the cost of populating the data on the console, on the software, if the ground control coordinate was wrongly inputted, does it have the provision when it's corrected, and instead of going back to start repeating the calibration exercise, can you generate to correct the erroneous data that are already inputted? Thank you very much.
Okay, so regarding the flight, when we are measuring, we record all the status of the GPS quality of the signal. So what does it mean is that together with the report, we know for every single point if we got the RTK fixed status, which is a mandatory for us to validate the result. We need to have this RTK fixed status because that will validate that our system was flying correctly. So actually from the flight here, if I go to this side, I will see first of all the accuracy of my measurement of my RTK. I think I have some interferences with my keyboard. I'm sorry for that. Okay, so you see, so now on the measurement, so I just toggled this button, and this is the RTK status. So if I have this, that means that I was always, so my receiver on board was always in RTK fixed mode, which means I had the highest accuracy possible. The second point here is that here, coming from the receiver itself, he has capabilities to determine this edge up and the horizontal precision and the vertical accuracy, horizontal vertical accuracy, and that is also together with the measurement. So That's to ensure that during the whole measurement we are getting the correct values. Alternatively, also before takeoff, we will see if there is a bad quality of signal, because we have those edge-stop values which are showing up into the screen. Actually, in my screen, I see the edge-stop values from the drone. So, for instance, here you see the edge-stop, and there are some defined values. The edge-stop is this horizontal deletion of precision. So, basically, for the drone, if it is above 1.4, we will not take off. So, if there is any specific interferences in the air, the receiver will detect it. But nevertheless, what we have so inside the box, actually, the RTK base station is inside this box. Outside was only the antenna. We use a high-end RTK receiver, which have also some interference mitigations algorithm. So it is supposed to be really protected against GPS spoofing, GPS interferences, so to work in a harsh environment. So that's for the
So regarding interference, this is just radio communication, so interference can happen. Even with that anti-spoofing, yeah, a powerful system can still do that. A rule of thumb, in a way, is to have a spectrum analyzer on ground, if possible, sweep the area, make sure that there's nothing going on. You could use it handheld, or, there are several options there on your radio communication, because your drone, to communicate with this, is radio, and someone can jam it and create some kind of interference for you. Your GNSS is the same thing. So having a sweep of that area before you fly your drone is good. I'll tell you a story. Does anyone remember when AWS in Lagos wanted, they did that drone air show? It was the one December, maybe 2021, I can't remember, or 2022. Well, we had to go there and do an RF survey to make sure there are no signals in that area that would interfere with the drones, because they had about 500 drones in the air doing the air show and stuff like that. Yeah, there was a hotel out at, I think it was on, it's Banana Island or something out there. That signal was so strong that if they flew those drones, a couple of them could fall because they will lose communication with the controller. So doing those surveys is a rule of thumb. Whatever your comfort is, scan that area, make sure nothing is going on before you start flying your drone. In this particular case, we did it. It's just that we just didn't announce it to say we're looking at that. We just made sure there is no signal there that would, or any kind of interference that would affect that. Just from a different part of our value proposition with NCC, they have a different drone that, still from Colibrex, is an AMU for spectrum monitoring. We have advised them, we've built it into their instruction manual to say, scan your environment, since they have those handheld spectrum analyzers, to make sure nothing is going on there before you fly your drone. Jamaica crashed their drone partly because there was an interference. The drone lost communication with the controller. They couldn't land it. They were trying to grab it and it just hit the ground and it fell and broke. Those things are expensive. So for me, spectrum analyzer, you could have 15,000 or even less to have a basic one. I will have that in hand, use it before I'm flying something that expensive. The OEM doesn't have to put that, but as engineers, think about that and protect that very expensive equipment by having, survey your environment before you do something. So I just wanted to add that to it, that how do you protect a very expensive equipment? So next question, if any. Oh, there's one more.
That was the second point of your question regarding the if we change the database after regarding the values. So there is two things. So the measurement that we made from the drone in the receiver or in the file, we have the raw values. So if I have to change something in my database because I made a mistake, I can reprocess my result and it will take into account the new position or the new elevation, the new coordinate. So that's clear. We don't need to redo the calibration. But where we flew is where we flew. I mean, if there is a mistake in the positioning of the drone because there was an error, mistake, for instance, in the RTK, then yeah, we could correct and see where we have been flying exactly, but the result, if it is not acceptable that we flew maybe 3.2 degrees instead of 3 degrees because we made a mistake in the database, then we have to repeat. But from an error from the facility database, it can be modified and it can reprocess the result, and that will work. Yeah. Next question.
Yeah, Arnold Bangura from Sierra Leone CA. I just want to ask if you had any challenges with the states you have provided services with for the authorization of the use of the for calibration of this aid, because since it's just a complementary, do you have any challenges in implementing this?
Sorry, to understand the question. Let's put it in that way. When you bring a new technology, there are always some resistance, sometime. Yeah? Allow me to explain you a nice story. When we started some of the measurement in one region of Germany, we had first some meetings with some of the local representatives of the DFS, and so also somebody representing the union. You know. So they were very much worried. What do you want to do with this drone? And this is now a change. And we have done that in the past, like that, with the telescopic mass and the aircraft and this and that. And it was very negative. We had the chance to have it once with us on the field, and he saw all the advantages. Yeah, and now he's one of the promoter of the solution within this organization. You see what I mean? Yeah, that's more on a personal level. Yeah, now in terms of real resistance. Let me be very, very frank and very open with you, and this is the way we want to work. I always say we are here working in a safety critical industry. Yeah? We have to be serious. Yeah? We have been at the beginning a bit cautious. Yeah? What can we really do with the drone? What can we announce and do? While we had some competitors, I'm not sure if I can tell them competitors, but there was one company at the beginning some years ago announcing a lot of things. Yeah? Finally, they failed. They are not on the market anymore. And actually, the feedback that we got from some stakeholder was, this is not good when such a company is promising a lot of things which actually are not possible. So that was also the purpose of this seminar, to really explain what we can do with the drone, what are the limitations. There are some limitations. Yeah? We believe and we show there are a lot of other advantages, and then it's okay. And then the resistance will go down. But what I wanted to say is resistance, otherwise, there might be still two types of resistance. One topic, one concern sometimes is always this issue with, is it ICAO compliant? And we always need some time to explain what does it mean to be ICAO compliant. I tried to explain a few things before. If you like, we can talk later and can give you even more information about, because ICAO is giving, with the DOC 8071 recommendation, and uncertainty limitation that we fulfill. Yeah, but ICAO, because sometimes people ask us, is this equipment ICAO certified? You have to be careful. ICAO is not certifying any equipment. You know it better than me. Yeah, ICAO is giving the guidelines and the rules. Yeah, and then there are other way of certifying that a product is in line with these rules. Yeah? So that's a little bit an issue at the moment, some resistance sometimes, because as I said, the drone operation is not really described in details in the ICAO Doc 87. It will come, but it's very, it takes some time. Yeah. The other resistance, but the message that we wanted to give today, and I hope this message have been well received, the equipment can be used within the ICAO frame. There is absolutely no problem, yeah, and it's very useful for all these use cases that we have mentioned. Yeah? The other resistance, yes, sometimes is operating a drone in airport environment. Yeah? I would say at the beginning it was quite difficult, yeah, because drone completely forbidden in airports. We have to explain what do we do, what are all these safety measures, what is the concept of operation, and you see we get the authorization. Yeah? But if we are talking about resistance, sometimes it takes a little bit time, yeah, to really convince all the stakeholders that yes, everything is in place and we can operate it. But allow me an additional 2 minutes. I really appreciated the exercise that we did here, and to be very frank with you. Yesterday we did some pre-tests, yeah, to be sure that everything is fine with the setup and so on. And we had also some discussion with the CAA here and with the tower. Yeah? What is the best way to do it? Initially we were saying, yeah, we just do a flight which is 4 minutes, which has a duration of 4 minutes. How is it? You have a planned schedule. Do we have this time frame to operate? Yes. So we did the first flight. It was actually a little bit short. Yeah? So we discussed and we realized, okay, a better approach in this case, because the airport is very, very busy, yeah, is maybe to combine 2 or 3 measurements in one flight, like we did, yeah, and to really ask for 10-minute or 15-minute slot. And this is what the gentleman did for us, and we are really, really grateful that they organized that. They freeze somehow the airspace for us. So what I want to say is, if the people are willing to do the job, if the people are supporting the activity, we always find a solution to do it. Yeah.
Hello. Yeah, thank you. I have a question. I'm Engineer Poku from Ghana. I work for Ghana Civil Aviation Authority, and I'm the manager NavAid. Yes, I would want to find out. My question has to do with GPS tracking. GPS tracking. Yes, in the case whereby the tracking is not good or that good, does the system stop automatically? I mean, the course of measurement, conducting measurements. Okay.
So there is 2 things. If the GPS is completely out, then the drone will stop. So that's one of the. We did not speak about the fail-safe of the safety feature from the autopilot. If there is no more batteries, if there is no more satellite, and several others. The second one is, as I explained, that if the measurement goes or lost, if we lose the RTK fix, then we do not stop the measurement. So if that was your question. So then the measurement will continue running. If we still have GPS, but we are normal 3D GPS quality, the measurement will not stop. So then but then from the ground station, it is the possibility to stop the measurement and to say, okay, pilot, stop, abort, come back home, and we stop the measurement.
All right, fine. So in that case, would there be any alert?
Sorry?
In that case, would there be any alert? Or alarm conditions on there?
Then we have alert. Yes, exactly. Okay. So this is what you see actually on that screen. That's what I explained. Part of the things which are seen. So here you see I have this field which is RTK. So when I'm in flight, this is green. So if it turns green, if it's on red, it means I have no more RTK. So when I am following the missions, I'm following a lot of different parameters during the flight. But also I have this really highlight, which will catch my eye. Say, okay, what is this? Ah, no RTK. Okay, land. No need to continue with the measurement is corrupted. So we have to come back. And that will be the things. And then we'll have to see if it is really a specific interference in the spot, if we had an issue in the link, because if someone disconnected my cable, or I don't know, because it can be a problem from my transmission, because I send from the ground the correction to the drone. So that's the possibility number one. The possibility number two is I'm getting really very low satellite because of, I don't know, interferences. I say normally we should be fine, but who knows? And then maybe we have to find in that case a different location for the measurement where we have less interferences, which is also the flexibility. I can quickly say, okay, let's fly 100 meters further away, and let's see if the GPS is fine at this position. That will be, but honestly, we never had this issue. So.
Okay, thank you. Another question: how far can your system go?
So you mean from the ground station to the pilot?
In the case of ILS, how far can you conduct measurements?
So as we said, there is the limitation currently that we apply to ourselves is the visual line of sight rule. So let's say that maximum that we are doing normally we limit to 500 meters from the pilot. So for instance, the longest approach that we have done, we were in the middle and we were flying 500 meters in one direction. Then we did 1 kilometer in the other direction, and then the drone flew back again 500 meters. So I did 3 measurements. 1 500, 1 kilometers, and 1 500. So that's the most reasonable flight that we can do. Again, it depends also on the location.
In the case of a VOR,
as I explained, for the VOR, we really fly quite close to the VOR. The measurement that we did in Nauheim, in this Frankfurt airport that you have seen, we were at a distance, I think, at 150 or 200 meters from the VOR. Yeah. And then there was some other specific measurement point where we identified because there was a problem for the landing procedure of the aircraft. So we did identify some different points where we were doing some specific measurement, small portion of measurement. But then we were moving the whole system because it was like 10 kilometers from the VOR, and we were doing a small portion of it.
Maybe one additional comment to this, always this issue of distance. And so, as I said this morning when we were outside, technically the drone is already prepared also to do beyond line BVLOS, yeah? Beyond line of sight flight. Technically we can program it like that. In general, to get a BVLOS approval, you need a kind of tracking mechanism in the drone. Also here we have already experimented different type of technology, but this depends a little bit country by country and what the regulators want to have. But it's basically possible. So don't be shy to adopt this technology. I would really see it also like that, and this is, at least for our company, for our concept, the strategy is really, when I said before, the drone is somehow very versatile. Our idea is really to have a solution which can be upgraded also later, which will continue its life somehow. Yeah, we've seen we have the PAPI additional payload, which can be added in addition. There are some regular. Let me give you an example. In Europe, there is a new rule. There is a kind of very simple drone ID message that you have to give. A special mechanism that has been installed in Europe. This was not requested at the beginning of the development, but okay, because it was a request from the regulator, we implemented it. We can have it. So that's really you have to see it also like that. The solution can also evolve over the time. And last but not least, in terms of distance, what you should know if you are really also interested, and this is actually also an argument that we have. For sure, such kind of this technology is not NavAid measurement receiver. All the software, all the drone is. I would not say it is a cheap technology. Yeah. So you invest in that, and you want to maximize somehow its usability. And one of the questions that we have sometimes is, how about doing using the drone to do the runway course, the complete runway course for the localizer? And let's assume you don't have yet a BVLOS authorization. Also here, let's be flexible, let's be creative. There is a workaround. And actually for some customer, we already tested that. There is also a manual mode in our software. You can take the payload and use the payload just as a kind of standalone receiver and put the payload in a car with an antenna. And then you can do your runway course. So, you see, you don't need to reinvest in another measurement device. You can use this one.
Yes. So good afternoon, and thank you for the opportunity. So my name is Samuel Kojo Zomelo. I'm also from Ghana, and I want to use the opportunity to thank the organizers, particularly the Nigeria CA and NAMA, for the opportunity given us to also participate in this demonstration. We have been on our own. As my manager said, we have been collaborating to see how we could go in this path, to look at how drones could augment our flight calibration. And it's been difficult even to get a demonstration. So for us to have had this opportunity, we are really grateful. I must say that having listened to you and what I have read, this initiative is very good. It's going to help us as developing states to manage some of or to meet the requirements that we're supposed to have. So your solution is very commendable. But I must quickly add that one would have expected. Okay, so let me apologize first, because one problem of being a post holder is that even when you're away from the office, they are calling you. So I was distracted during the presentation. So perhaps you have answered my question, but I would ask again. Would have expected to see the flight calibration results by an aircraft side by side with your results. For instance, what was the last flight check on this same ILS compared to yours? So we could see whether really this is able to help for the work, for what you said it does. You see? Okay, so we'll take it one by one.
Thank you for the question. It's we would have loved to do it also together with a flight inspection the same day, because yes, it's the best for us. For us, it's the best way to prove that with the equipment we are so accurate. You cannot imagine. I will come to the accuracy a bit later. But yeah, this was not possible, I think, for some organizational reasons and so. But I don't know if you heard when I was speaking in the first session about what we have done with the drone in our development phase, and with a very long validation process, and to get it validated by the DFS, which is our major customer so far and a kind of reference customer. We did this experience, or not only experience, we did this validation to compare the measurement of the drone together with the measurement of the flight inspection. Yeah? And they match completely. And actually, when we do these regular measurements, very, very often the DFS people compare the value with the last value from the flight inspection to have an idea if they see any big deviation or whatever. So it's here we could not do it, but it can be part of the process.
Understood. So maybe,
and maybe one word about accuracy. the interesting thing here is, you have all seen what is installed in a flight inspection aircraft. Very expensive, very good measurement equipment from Rohde & Schwarz and others, no doubt. Very heavy, very good, and so on. Here, we have a small drone and we have a receiver with a weight of 800 grams. Yeah? So everything very much compact and downsized. So, somehow, I could understand that you would challenge us in saying, how can such a miniaturized receiver compete with a high-end laboratory receiver from Rohde & Schwarz, whoever, in a plane? And now we have to come back to what we are doing. And one of the really, really big advantage of the drone, it's its ability to be positioned at centimeter level where we want to have it. Can you ask the flight inspection aircraft to be so precise in the air? No. What I want to say is, yes, if we would compare, maybe, and even that is not given, even in the if you do laboratory measurement for the calibration and for the specification of the receiver, even the original specification and tolerances of this receiver are very good, are comparable with the high-end equipment. Yeah. Okay, the high-end equipment might do more. Yeah. But somehow what I wanted to explain is we can compensate that by the fact that we are flying very, very precisely. We are also measuring much nearer toward the aircraft. So we also need this additional accuracy. But I hope you understand what I want to say is at the end it's a threshold of the different parameters.
All right.
Do you have more questions?
Yes.
Okay, please go ahead. Well, I just want to comment on your last. It is my fault. Colibrex actually requested for the last calibration record that NAMA has. I didn't secure it, so we would have had it side by side, or do some comparison. So I failed on that part. I failed you there, so I'm sorry about that. But they did request for it. I just never secured it. So yeah, but no, for this airport. Right, for this airport, they requested for runway 22 specifically. I just couldn't secure it. So yeah, sorry. Go ahead, please.
Do you want to add?
Yeah, just one thing. It is also in the plan from the software to have actually a mask of the last flight inspection, so that you can compare directly in the software. So that's in the plan. We have obviously a roadmap with improvement of the software. And my idea is, after measurement, I have the mask or the last inspection, and then automatically I have green, 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 green. Fine, you don't need. You know what? So that's what I want to have in the software.
And actually, we are also preparing some kind of comparison table between flight inspection data and our drone measurement data. It's a little bit tricky because, especially here in Europe and in Germany, and so there's always some constraint about giving out this data because it's considered as secure data, blah blah blah. So we have to do it anonymized. Yeah, but that's something we are also preparing.
Great. My second question is that, so I need to convince my boss that we need to go this path. We need to procure this system because it's going to help us do better maintenance of our ILS or VOR. We will be able to do our ground checks. And we need to convince them. And we are very much aware that these systems have lifespan 25 years. Can you convince me that if we spend some amount on this system, it's going to help us to be able to, the usability of how much we are putting in, because I'm proposing a solution and it should be able to last, because otherwise we would go buy our own antennas, which is less costly. We will raise and do the physical checks. But I need to convince my bosses. We need to spend some money on this and make sure that we're able to work or provide the needed results as ground checks to augment flight check. Right. So what is the durability, or what have you in place to help over the 15 to 20 years lifespan of NavAid?
Okay, well, actually, first of all, regarding the question about ground measurement and the measurement done by the drone, this is clear. There is no debate. I mean, the quality of the drone measurement. First of all, with your antenna on your point, you will be like a few meters above the ground. Here, the drone will be, as Luke said, the drone will fly really accurately, and each time you come to the same airport, you will repeat the same flight. You don't need to program any new flight. You will just repeat the same measurement and compare exactly the same measurement from March in September. And if you do it every month or if you do it every 6 months, whatever you are doing, it will be fairly easy to check your measurement. For the glide path, it's really simple. Huh? The glide path, what we do in Germany, I go there, we make 3 up and down, up, down, up, down, up, down. ILS glide path calibration is done. See you in 6 months. I'm not kidding. This is exactly what we are doing. I spend more time taking the equipment out of the box, installing, than the measurement itself. The measurement is 8 minutes flight. Then it's finished. And then we go to the next runway if there is more runway in the airport, and this is everything what we are doing. I mean, that's so the operational cost, how quick we do it, it's really impressive, and you have the full measurement. And then you can, and obviously in terms of security, we're talking about a critical safety system. You can detect also you can be sure that the system doesn't have any problem, or you can detect quicker the problems. And so that's, let's say, in terms of comparison between the ground and the drone, I think there is no debate. I mean, in particular, if, for instance, I don't know if you have your telescopic, if you have a telescopic mast, telescopic vehicle. So, for instance, that means that the glide path measurement, you cannot really do glide path measurement. You are really low then to make this measurement. So then you are definitely a big, and then you are ready to reduce this flight inspection.
Yes.
Again, the target is to reduce this flight inspection.
But that's not dependent on you per se to say.
There's 2 things.
Yes.
Your ministry, the entity which is in charge of defining your rules. So we'll have to convince, so you have to provide measurement result and check, look, this was the flight inspection from January. We did the measurement in February, in March, in April, and maybe for 6 months you do a measurement every month, and then you show, I have plus minus 2 microamp difference. So my correlation is always there, okay? And then they will have to decide. So you have to convince and that's more your job, to convince your regulatory body to extend the flight inspection interval, for instance.
And in terms of, you ask about the next 20 years, I hope we will still be here in 20 years, especially me. No, as I said before, it's also something which is future-oriented. We should also consider PAPI option, like I said before. Something we have not mentioned yet, because, this is, as I said before, maybe the difference between some companies promising a lot, but at the end not delivering it, and us, where we are German, we want to be sure, what we do. Now we are, for example, also working on the possibility. We have still to validate a few things, but we are working on also a DME option. So the possibility to use the NavAid drone to test, to do an interrogation of the DME and to measure the distance the DME value. So you see, you have also to sell it somehow if you want to sell it, if I may use this word, to your ministry or decision makers. You're also preparing the future. You are also preparing the future with that.
Just to add from a cost perspective, right? If you want to convince either the regulatory side or your management, has to do with cost somehow. Well, there are options. So there are 3 ways or 3.5 ways you could acquire or use this, for example, right? You could buy the whole thing, train your people, and then you run everything. So you're dealing with the capex, and then you now carry along with the operational cost. You're doing it all over, right? You do the foreign training if you want, domestic, and then you run everything. Just like, for example, Nigeria has its own calibration aircraft. Have the pilot, and you do all of those. That's one option. Second option is you buy it, but then you have a consulting entity come in and operate that. Because what I have seen actually with a lot of departments, government departments, they are short-staffed. I know of one department here, I won't mention the agency, they have only 5 people. They are regulators. So how can they have just 5 people to do the regulatory aspect of things and then do the operation also? So outsourcing sometime is a way to have an early entry with less capital spent to now gather that data. The example he was giving over the every month, do the measurement. So if you go the service base, managed service or calibration as a service, right? You don't need to buy, that's the third option. You don't need to buy any of this. You just call an entity, company X, or you can call Live Yourself because we're working on a model of that type, right? We'll come in with the drone, whatever airport you want, do the measurement, have a drone pilot and have an analyst. You're paying for just for the service. And you don't have to do that with your CapEx, where it has to go through procurement and tender and all the, all the drama that goes with that. It's a PO aspect. Just like you will go out and buy, a paper, or somebody is going out for, like the way you process DTA or other things. Just services, that's it. Then you use that as the entry point to vet the solution, that's on one side, gather enough data to convince your management long-term what if you want to invest in doing this or not, right? So service-based is something that you need to consider. And I know, Joel, don't hide behind there. I'm gonna be talking about you there. He has a completely different perspective to it. From day one, the CAA in Uganda, we're not looking at buying this. It's looking at it as a service. That is a way to go without spending so much, without making your management thinking, oh, I have to spend millions to buy this. No. Bring it in, it costs of, if you're looking at a service, okay, flight for the drone itself, shipping it in, flight ticket for the 2 engineers coming in, if you're not doing it domestic, and the few days they're spending on doing that, you find that cost is not crazy cost. So you could use cost-wise in terms of cost of ownership or cost of operation or cost of the service, as you mentioned, as a way to prove to your management that, look, this thing is important to what we do, it doesn't cost so much. But if you're not convinced, then you could decide to invest in buying and training your people, or you just do it as a service. I mean, privately I can crunch the numbers for you to see that, boy, doing it as a service is far, far better than trying to have the drone and own it and worry about signal interference and then your drone falls down and break or any other thing. Because the training, once you have an SLA between you as the supposed operator, right, or the regulator with an entity, then you hold them to it. Make sure their drone pilots are trained properly. Make sure their analysts have all the necessary training, and you hold their feet to fire to make sure that they do that measurement and compare to what your main calibration aircraft has done. You just sit easy. So that's one other aspect to look at. Don't go and maybe give your management this big budget and they will just throw it away. Go the service route and try it. That is possible.
All right. For the sake of time, maybe I'll hand over to others who will do some consultations behind after the meeting. So
with what we have just finished saying, I don't know, you have our emails, we have put in our emails. We would like to see the different cost analysis, the cost of buying, the cost of service, and all of this analyzed. It is good because when we are going back home, we have something to go and discuss with our board or the state. So it is good that we have some an insight into this information, because that will be better. Because I can't return back home and somebody asks me, how much do you think will the drone cost? I said, I don't know. So how much do you think when you are talking about service, they can come and render the service? What will it look like? Of course, I'm not areas like flight ticket, hotel for the two personnel, and taking care of them. That can be handled sideway. But the cost of the service, we must have a fair idea. So when we go back, when we are presenting some of these things, we are talking with a fair knowledge, informed judgment, so that when we discuss with our board, they can be able to make an informed judgment in whatever we may be telling them. Thank you.
Yeah, there was a kind of currency we used in Nigeria way back, cowries, right? You remember those ones? Yeah, I'll tell you the cost in cowries. Okay, let's do this. You would not get that analysis today or even tomorrow. But I know for you to start putting together your report about your visit and so on, you start to deal with it Monday. Promise you would have it. We've looked at those numbers, you would have it. No issues there. But if I tell you a number in the air, do you know that this event right now is being streamed online? So it's like a trade secret, right? So we'll give it to you because you asked, to your email. Yeah, you can go and post it on YouTube or X or something else. Well,
no, I don't think that's why we need it.
Yeah.
We need it to make an informed
so we'll get that for you.
Yeah.
But jokes apart, right? For us in Africa, we have to leapfrog. The banking system in Nigeria, I can tell you this, is better than the one in the US. I can pay my taxi driver, boom, boom, with. You go to, you do Momo and something. Though it didn't catch up here, but in other countries you could do it. That is really leapfrogging. Banking in America is they regulate that and so hard you can't even do anything. Look at telecom. Yeah, we did not dig everywhere and put landlines. We tried a bit, but we stopped. GSM came, we just boom, and it's happening here. Bringing ASECNA, there are a bunch of countries, maybe around 17 or more of them, they've tied into a knot. You can't move. You can't even do something. Check your contract very well. And a lot of regulators that are in some of these countries do not even know the agreement that has been signed with that entity. You can't do anything. So for us, we need to leapfrog where we can stay safe. Make sure that our citizens that start to fly, because flight traffic is increasing in Africa. That means we need to, on our own terms, sorry guys, on our own terms, we need to be able to do it. So do it at a cheaper rate. Service-based or using a drone is, you will see the numbers, is far, far less. It doesn't eliminate the traditional one, no. You will still have to do it, but then you're having cost savings because you've introduced a complementary technology in there. You've gone for technology. It's that simple. So, any additional questions?
Thank you very much. Just to compliment you for the work you're doing, just to add that for us, the directors and managers and decision makers here, actually, the Africa Civil Aviation Commission has been looking into this and had commissioned a team to look at the use of drones for ground checks, and even intend to present a paper, hopefully at the upcoming assembly, ICAO assembly. If the paper passes, then there's a likelihood that Africa may be making a case for the use of drones for ground to augment flight testing. So I just want to call on decision makers or influencers here that it's high time we look into this matter and add our voices to whoever we need to talk to, so as to help. This, we have seen the enhancements that it brings on board, and it's a very good thing. We have looked at it in the past. When we crunched the numbers, it was not so easy. I mean, there was much disparity between the flight testing and this. But then, the issue is it replacing? We said no, it's augmenting, it's supposed to. And we are still not been able to get to this point. But just to say that, for those of us here who can influence decisions, this is a good call, and let us support it as Africa. Thank you very much.
I'm going to add to what he just said. Who attended the last IFATSI conference? Is anybody in here? Yeah, the one in the US, I think, last year. You did. Okay. Through the grapevine and through part of my research looking at, I know for the African region and other regions also, there is a committee set up to look at that. And for Africa, I think there should be a conference in South Africa coming up maybe in June or later this year.
November.
Yeah, in November. Okay. Each of these regions have been mandated to look into NavAid drones, navigational aids using drones and so on, so that either a position paper or a kind of a push would be made with ICAO to recognize or to at least have something to say about this. Well, guess what Africa is going to lead now? Here we have Nigeria, we have Sierra Leone, we have Uganda, we have Ghana, and then we have Kenya online. They connected online because this is also streamed, and South Africa also. Okay, so that's about six countries. So when you go now for the next IFATSI conference and you're talking about this drone thing, it would not be that, oh, I Googled or I looked at on YouTube. No, I attended. I've seen it. I've asked questions. So things are changing because we're probably leading the world. I'm not sure if there's anywhere else that you've been to that they've asked for this drone because this is just a publicity stuff. It's a sensitization type of an event, really. Out of this, you will not become expert in doing this, no. Out of this, you would not have just gone and make a purchase the next day, no. It's one step closer to say, hey, this thing is coming, it is possible. Let us look at it and evaluate it and see what we can do with it. Well, don't buy outright. You could do the service, or if you could afford it, yeah, go buy it and do what you need. So when you write that report going forward, it's going to be more, hey, we've seen it, or actually this is crap, it doesn't work, or, well, it has some improvement, it has some ways that it needs to grow, but it looks promising. The report out of the African region is going to be different. And I'm hoping those that will contribute to it, what you would write and add to it, let's see. Because now we are pioneers looking at this, and all other regions, their own report will not look like what will come out of Africa because of this event. So just as my brother there, Samuel says, we need to make that noise, make that input, change the narrative. Then all the trouble each one of you is having with your, either with your regulatory part or with your management, will start to change, because they will hear from ICAO. Some of you have shared what I call a customer references. We insisted to put emails and phone numbers in there. Each of those emails and phone numbers are valid. These are your counterparts around the world that are actually using this system. They have a reason. Mexico has 12. They ordered 12, and they're situated in different airports and so on. And there are a few others. So look at that reference, and based on this also, if you contribute to the report, then you do that. So I think that we're still far from that end goal, but we're inching closer and closer there. So, and thank you for your comment. We appreciate that. Any other questions? I think we should be drawing this to a close if we don't have any further questions.
Sorry, I just wanted to add to what was observed in the practice section, and some observation. I noticed that the flight plan submitted gave us the impression that the unit is equipped with mode A, that's ability to accept transponder code, and mode Sarah, which mentioned the aircraft ID. If at all, in the absence of mode A, we could use the ID to be able to have a surveillance of the operations of the facility. That was what actually part of what gave us a setback when I came and asked that. You told me this. So I want to believe you have a version of this that are equipped with this capability, right? If you are to market it to customers. And no, I'm not finished. Then secondly, in the flight plan, the communication equipment stated was based on emergency. What you gave us was that under emergency communication available is other radio communication with control tower, with ATC. Then the drone having the capability of homing straight to point of departure. So I think that's an operational requirement. What is expected of a drone operating within the airport is to have the capability of having the drone pilot, having two-way communication with the control tower or the controlling authority, as if it's a car, because the drone itself is an aircraft. And so, having that in mind, we anticipated that there will be a pilot-controller communication to avoid infringements. So I'm trying to solicit if your version can include those parameters like the ADSB out on in Mozilla, or if possible transponder. I know you might be counting on total payload. We want to reduce the total payload on this. So if there's a version, since we have the customers intended to have it, let it be that coordination with ATC will not be a problem that will create risk in the operational area, because the target operational area is the approach path, which is the most critical end of flying. So thank you very much.
Well, regarding the ADSB, there is a possibility to put on an ADSB, but which is, let's say, a drone version of the ADSB Mod S transponder, which means it won't be the 25 watt, so this is always the question about what is the requirement. If the CAA come and ask me to have a 25 watt transponder like in an aircraft, that will be a big problem, So if there is, if it is accepted to get, first of all, there is this company which is Avionics, making a really micro device, no weight and very low power, which is sufficient for the tower to sit on their control system. That is fine. The second one, we need to be sure that the tower want to see us, because sometimes they don't want. And the third one is, still in that case, it's more, maybe a little bit more of a meeting before with the controller to explain them what we need. And then we say we need a flight of 4 minutes, we need maybe 6 or 7 minutes, you know, that we have a better margin. But yeah, this ADSB is an option, but not the normal ADSB for aircraft.
Yeah, and maybe we should, if you allow me, see that topic a bit from a broader perspective, because you are CAA and you see it really. Okay, I want to have this drone seen like an aircraft, yeah, which I understand and I respect. There are means to do it. What is interesting to notice is, in other parts of the world, some representative of the tower say, no, it's not an aircraft. I don't want this device in my screen. It's not an aircraft. It's also flying. I need to consider it, but it's not an aircraft. I have enough to do with all my aircraft. You really have that also. So when I say you have to see it from a broader perspective, what is anyway coming more and more? You know, we are this drone for this application, but as I said this morning, there are so many other applications with drone. Meanwhile, yeah. In different countries, they are also now more and more looking into this UTM, in analogy to ATM, yeah? So unmanned traffic management system. And here there is a big debate how to integrate UTM into ATM. Yeah? They are discussing that since years. There are progress, but I have the impression it's still a long way, because people do not have all the same interest here. Yeah? Having said that, yeah, there are different safety measures in place, like we have seen, and the tracking, if for certain operation the tracking is necessary, we can do it. The first experiment we did in Munich some years ago, we had the tracking, yeah? Not based on ADSB. We have a kind of proprietary solution developed in Germany by also one subsidiary of DFS. Now I tell you a small story, just to show you how complex it is a bit, this issue of integrated it really as a kind of aircraft. Imagine the situation, it's a little bit crazy. DFS, one of the biggest ANSP in the world, has a own subsidiary which is called Dronic. It's a subsidiary of DFS and German Telecom, and they have developed a tracking device and a complete UTM platform. Yeah? So we can take this device, put it on the drone, and you can track the things. And it is a subsidiary of DFS. But the people from the DFS in the tower, they say, no, we don't want that. It's developed by their own company, but they say we don't want that. So it's still a long way. But yes, there are, and sometimes there are also some workaround. What we manage, for example, also to do is, even if it's a kind of, as I said, workaround, the exact positioning of the drone, we have it here on the ground control station. So there are also some interface, yeah, to show this position on a screen in the tower. Also possible. So we have to see.
And your second question regarding the radio license for the pilot.